In this video, I will discuss the training guidelines put forth by the American College of Sports Medicine, designed principally for adults whose goal is to improve muscular strength and endurance. I will also address the underlying mechanisms responsible for these strength training adaptations. I will conclude by examining any potential differences between men and women with regards to both strength as well as training adaptations. As with endurance training, the overload principle also applies to strength training. Thus, if you habitually overload a muscle group, it will respond and adapt. Based upon your personal goals, you may wish to increase your muscular strength, muscular endurance, or simply want to maintain your current level of strength. The major variables to be considered in optimizing strength training adaptations are the training frequency, intensity, number of repetitions per set, and the number of sets per session. This table describes the optimal ranges for these variables depending whether your goal is to maximize strength or to improve muscular endurance. The intensity is based on a percentage of an individual's 1 repetition maximum, or 1 RM. This is defined as the maximal force a muscle or muscle group can generate in one lift or repetition. To maximize strength gains, a higher intensity or percentage of your 1 repetition maximum should be used with fewer repetitions per set. Over time, as you become stronger, you should increase both the number of sets as well as the intensity. It is not uncommon for experienced weight trainers to perform just 1 to 3 repetitions per set at extremely high intensities approaching 100% of their 1 repetition maximum. Split routines are also common among more advanced trainers, where specific muscle groups are targeted one day and other muscle groups are trained on a separate day. If your goal is to improve your muscular endurance, as you would imagine, you perform more sets and repetitions per set, but at a lower intensity or percentage of your 1 repetition maximum. Increasing muscular endurance would benefit everyone, but is also a critical component to many sports such as soccer, tennis, swimming, cycling, and running. This figure demonstrates the timeline and mechanisms for strength gains when a previously untrained individual begins the strength training program. Please notice that the gains in strength can be realized very quickly, well before there is an increase in muscle mass. This suggests that these early strength gains are due to neural adaptations in muscle, such as an improved ability to recruit muscle fibers, better coordination, and motor learning. These neural adaptations, which can occur rapidly, generally peak around the 8th to 10th week of training. After that, any further increases in strength are due to muscle hypertrophy. Muscle hypertrophy is defined as an increase in muscle mass resulting from an increase in the cross-sectional area of muscle. This increase in mass and size is primarily due to an increase in muscle contractile proteins. Based upon your genetic makeup, the increase in muscle mass and strength will eventually plateau. This plateau can be frustrating to some individuals since they continue to train but fail to see any significant improvements in strength and size. As a result, some individuals resort to taking the performance-enhancing drugs known as anabolic steroids to stimulate further increases in muscle mass and strength. I will discuss anabolic steroids in detail later in this module. As discussed, one's genetic makeup plays an important role when considering the overall adaptations to strength training. Other factors can influence the extent or degree of these training adaptations. We have already discussed the nervous system or the neural factors. Key hormones such as testosterone and growth hormone play a vital role. As covered in our protein metabolism video, the nutritional status and the need to remain in positive nitrogen balance is essential for continued increases in muscle mass. The concept of muscle plasticity, as defined in the previous video on endurance training adaptations, also applies to strength training. However, the primary signals, as well as the eventual outcome, differ greatly between endurance and strength training. The primary signals during a single bout of strength training include the amount of tension or load placed on muscles, as well as the degree of muscle stretch. Over weeks, with repeated strength training sessions, this will lead to altered gene expression, resulting in an increase in the synthesis of contractile proteins in muscle and the eventual increase in muscle mass or hypertrophy. Here is one of many studies demonstrating the effect that just one strength training session has on skeletal muscle protein metabolism. After subjects perform multiple sets of bicep curls, the rate of protein synthesis in the biceps was elevated 4 and 24 hours post-exercise. This increase in protein synthesis was the result of altered gene expression over time, as indicated by the elevation in RNA activity in the biceps. Thus, this reflects the early stages of strength training adaptations, leading to an eventual increase in muscle mass and strength. After months of strength training, notice that the increase in muscle mass or hypertrophy is due to an increase in the cross-sectional area of both type 1 and type 2 muscle fibers. With heavy strength training, there is a greater increase in the size of type 2 compared with that of type 1 muscle fibers. This is further supported by the observation that post-training type 2 to type 1 fiber ratio increases, as shown here. Finally, notice that the principle of reversibility applies to strength training as well. The use it or lose it concept is clearly evident when the trained limb is immobilized for a period of time. Without the training stimulus, the muscle begins to atrophy, as indicated by the significant decrease in fiber mass and area in both type 1 and type 2 muscle fibers. As lifting weights relies predominantly on the anaerobic pathways for ATP production, it is not surprising to find that these metabolic systems adapt to strength training program. The intramuscular concentration of our immediate energy stores, including ATP and creatine phosphate, as well as glycogen, all increase with training. Further, the enzymes involved in the breakdown of these stores for ATP production increase as well. This will allow for a more rapid and extensive production of ATP to meet the energetic needs during this type of power-generating activity. Now, let's take a look at whether there are any sex differences when it comes to strength training. First, let's examine the muscles themselves. Men typically have a greater muscle mass and cross-sectional area. As such, men are able to generate a greater maximal force and power simply because they have larger muscles. However, as shown here, when normalized for cross-sectional area of muscle, there is no difference in the intrinsic ability to generate force and power between men and women. Thus, for a given amount of muscle, men and women demonstrate similar force and power characteristics. This figure demonstrates that when previously untrained men and women begin a strength training program, no differences exist in the percentage of strength gain between men and women. As mentioned above, the early increases in strength are associated with neural adaptations, and these appear to be similar in both men and women. Differences in strength gains may become evident with more prolonged training periods, as men have the capacity to increase their muscle mass to a greater extent simply because they have 20 to 30 times more testosterone. Testosterone has pronounced anabolic effects, significantly contributing to muscle hypertrophy and strength gains after the neural adaptations have plateaued. In summary, adherence to proper training frequency, intensity, and volume are essential to optimize strength training adaptations. Neural adaptations are responsible for the early increases in strength, while an increase in muscle mass or hypertrophy are responsible for the later strength gains. When the stimulus is removed, as with detraining, muscle atrophy will occur, and muscle mass and strength will revert back to pre-training values. Sex difference can exist in absolute muscle mass and strength, but intrinsically, no difference exists in the ability to generate force and power.